All right, let's take a look at a linear programming problem here. This is an application. This is a story problem, pretty common type scenario here, where we're going to be given a story that involves, something that needs to be optimized or maximized, and then given some constraints. So there's going to be some things that are limiting us, and we need to come up. We need to come up with the objective function. We need to figure out what our x and y are going to represent. We got to write the constraints, do the graph. We got to do the whole thing here. So let's give it a go and see what happens. It says a farmer is going to divide her 60-acre farm between two crops. Seed for crop A costs $15 per acre. Seed for crop B costs $30 per acre. The farmer can spend at most $1,500 on seed. If crop B brings in a profit of $280 per acre and crop A brings in a profit of $160 per acre, how many acres of each should the farmer plant to maximize profit? Okay, so one of the first things we want to identify is what are we trying to maximize or minimize? And in this case, it's profit. So when you're thinking objective function, that's where we want to look. That's where we want to go. Our objective function has to deal with the maximization of profit. So we want to make as much money as we can here. So this equation, which we'll call or set equal to P, remember you just use a third variable there, should involve the profit side of things, or the money that they're going to bring in, right? So we have crop A and crop B. What I'm going to do, I'm going to let crop A, so the amount of crop A, I'm going to let X be acres crop A, okay, and I'm going to let Y equal acres of crop B. Okay, and the reason why I'm doing that is because that's kind of how everything's given. Crop A costs this per acre. Crop B is this per acre. And again, that's what the question asks too. How many acres of each? So the question usually identifies your variables for you. Okay. Now, what we need to figure out is how much money are we going to make off of crop A, and how much money we're going to make off of crop B. So we can find that in the problem. It says if crop B brings in a profit of $280 per acre, well, to us, that's our Y variable, so it's going to be $280 per acre of crop B. Okay, so for us, we would write that as 280 times Y. So we take 280 times each acre, each Y acre of crop B, and crop A brings in a profit of $160 per acre. So in that case, our profit would be $160 times each X, each acre of crop A, plus 280Y gives us our P. So there's our objective function, and that's usually the easier thing to identify. You look for the question mark, you see what you're solving for, number of acres of each crop, that's your X and Y, and then what about those acres? For us, it's profit. Okay, then we got to come up with the constraints. Okay. And the constraints are anything that are going to limit us. Okay, so there's two we can kind of start with, and these are what we kind of refer to as the real world constraints. That's just going to be the fact that we let X be acres of crop A and Y is acres of crop B. It wouldn't be physically possible for us to have negative of either of those. So first thing we'd say is X should be greater than or equal to 0, and Y should be greater than or equal to 0. It would be okay to have 0 acres of either crop, but we can't have a negative amount of either one. Okay. Then let's go back in the problem and let's look for things that are limiting us, right? So it says a farmer is going to divide her 60 acres. That right there is a limitation. Okay. There's a limitation there because we only have 60 acres to work with. Okay, so there's going to be one constraint dealing with land available. We'll figure that one out. And then it says seed for crop A costs 15 per acre. Seeds for crop B costs $30 per acre. The farmer can spend at most $1,500 on seed. There's a limitation. We only have $1,500 to spend, right? So we have a land constraint and a money constraint, and then the rest of it just talked about our profits. So I think those would be the two constraints we want to come up with. The 60 acres is going to, remember, be split up between crop A and crop B. So this one is kind of that sneaky, easy inequality there, equation that we come up with our systems, but it's just going to say X plus the Y has to be less than or equal to 60. Okay. Do we have to use all 60 acres? Nope. Can we use more than 60 acres? Nope. So X plus Y then is less than or equal to 60 is going to say that for us. The sum of our crop A and crop B needs to be less than or equal to 60 acres. Now, chances are we're going to maximize that. We're going to use all 60 if we want to make the most money, but you never know. Depending on the constraints, we might not want to. Okay. The last one is dollars. So we have at most 1,500. So that means we could use all the way up until $1,500. Okay. So we'd have another kind of less than 1,500. And then what does it cost per acre of crop A? Crop A costs $15 per acre. So the sum here, our total cost spent on seed would be 15x, $15 per acre X plus 30 Y, $30 per acre Y. So we can see those numbers kind of in the problem there. So that's it. That's the last of our limitations. Now it's time to come up with that feasible region on our graph here and see what we can find. So this is where you can go to desmos.com or you can get this thing graphed by hand pretty quickly as well. Okay. So here are the first two. We have x is greater than or equal to 0. That's going to be a vertical line right through the origin. So we're going to get that one put on here. And we want to be greater than that. So that's going to be everything just to the right of that line. We have, this first two, kind of just get used to those. You see those quite a bit with these, especially the application pieces. It's just going to limit us to that first quadrant, right? Upper right-hand quadrant where both the x and y are positive. So here's the second one. Y needs to be greater than or equal to 0. That's just going to be from here and up. Okay, and let's see if we can get that one graphed. Flatten it out a little bit here. There we go. Okay, so we're limited to this region right here. Now, the other two, remember we could get into y equals mx plus b real quick, or otherwise jump over to Desmos and plot those things. For us, I got this one down pretty quick. We're just plug a 0 in for x, we get 60 for the y-intercept and the x-intercept. So we're going to have one line coming here. This is the land constraint. Okay, let me grab that. Something like this, but it's just going to have an x and y intercepts both at 60. And the other way to look at it, just minus x over the other side, we get a y-intercept at 60 and down 1 over 1, down 1 over 1, or go down 60 and over 60. Okay, the other one, a little more complicated equation, but if you get that solved for y, we'd be looking at, y equals, let's see, just minus the 15x from both sides. My pen is freezing up here. Grab a color quick. We'll just minus 15x from both sides. We'll go ahead and divide both sides then by 30. Okay, and we'll get y then is less than or equal to negative 15 over 30x plus 1500 over 30, which will reduce for us to be y is less than or equal to negative 1/2 x, and then let's see, 1500 divided by 30, I believe is positive 50. So there's our y-intercept at 50, halfway between 40 and 60, and then we're going to go down 1 square, run 2 squares. Since they are equal grids, we should be okay to do that. Otherwise, if we go down 50, okay, we'd have to run 100. So you can kind of count that slip out either way. Down 50, again, a 1 to 2 ratio. So every 1 I rise, I need to run 2. So down 50, run 100. The x-intercept would fall right here. Okay, so let's get that one on the grid here too. And again, Desmos is a real good option here for as far as coming up with these graphs, help you kind of get these these points in the right spot and find those intersections. Okay, you don't need it. You don't need Desmos. You don't have to rely on it, but it does kind of make these problems a little easier. All right, so let's kind of scroll back up here and see where our shaded region falls in. So we know we're in this upper right-hand corner here. We kind of have 1, 2, 3, 4 different regions to deal with. So this one says y would be less than negative x plus 60, so we want to be under this line right here. So that's going to be either this little region or this region or this region. Those two are the ones that satisfy less than this line. The other one is less than also. So we also need to be underneath this line, which would be this region here or this region here. So you can see the region that satisfied all 4 of our constraints falls in this one right here. Okay, so it's bounded, which means there's a maximum value in here somewhere for sure. There's a min and a max. And we just work our way around this circle then and kind of identify each of those vertices. Okay, so here this one is the y-intercept. So we know that's at just 0, 50. Okay, so there's one. We have one here. Okay, we have one right here. And we have one right here. So this one's at the origin, or 0, 0. This one's our x-intercept at 60, 0. And then it's just a matter of finding this intersection right here. And it does fall on 20, 40. Now, there's no reason why, if you have Desmos or a graphing calculator, you can find that point pretty quick. Don't trust your graph necessarily, but this one, we could actually solve a system of equations if we needed to find that intersection. So this would just be, the line, y equals negative x plus 60. This one right here, this other line, is the line y equals negative 1/2 x plus 50. So if we have both those, you can always just solve that system out, right? And so I'll get negative x plus 60 equals negative 1/2 x plus 50. And if we just kind of combine our like terms, we add 1 to both sides, we get positive 1/2 x. We minus 50 from both sides, we get 10. And we divide both sides by a half, we'll get x equals 20. And if we back substitute that, it's just negative 20 plus 60, we get y equals 40. So if you are stuck on that, you can use algebra to find those intersections. You just need to identify which line it is. Don't even worry about it as inequality, and then solve the system out from there. So there it is. We have 4 feasible points on the vertices of our feasible region. Let's just go ahead and plug those in. Let's make a little table here and see if we can't figure out which one's going to maximize our profit. So we got x comma y. Our profit function is just 160x plus 280y, and then we'll give the one that has the maximum p. This will tell us kind of how we should plant our crops here. So we have 0 comma 50. We have 0 comma 0, which we could probably rule out. I don't know if we would want to even take the time to plug that one in. We're just going to get 0 there. We have 20, 40. All right, we got 20 comma 40 there. I took some time to just move some things over there. Sorry about the pause. But we do have 20, 40 as a feasible point on the vertex here, and then 60, 0, comma 60, comma 0. So with that, let's go ahead and plug each of these in and see which one gives us the biggest p value. So we got 160 times 0 plus 280 times 50. Okay. If we just grab your calculator times that, 160 times 0 is just 0. 280 times 50 is going to give us a maximum profit of $14,000. Okay. Again, 0, 0. There's no chance of even plugging that one. It's just going to make 160 times 0, 0, 280 times 0, 0. So we just get a profit of 0. That's not going to be your maximum profit, right? But that would be the minimum point. That's, at least we wouldn't lose money, I guess. So let's go ahead and skip down to the next one. At 2040, it'd be a 160 times 20, okay, plus 280 times 40. And if we go ahead and plug that in, 160 times 20, we get $14,400. So we got a little higher profit there. That's kind of nice. And then what about 60, 0? So if we went P here equals 160 times 60 plus 280 times 0. Same thing kind of happens here with the 0, just knocks it out. 160 times 60 is only $9,600. So the most profit that we're going to make here on any of these options would be $14,400. This is our optimal solution then. So the final solution to our problem here would be to plant 20 acres 20 acres of crop. Oops, missed the R there. 20 acres of crop A, and 40 acres of crop B. Okay, but there it is. There's the best solution available to this particular farmer.